HVAC gals and guys. Today I wanted to go over metering devices and the purpose of them, the function of them, the system charging method when it comes to metering devices, and the different types of metering devices. Right here I have some TXVs. Sorry about that background. I have another oldie right here. And we have a piston. We're going to be using this coil for a lot of different videos going forward, you guys. So I didn't really want to detach it just for this video because I'm going to use it later on for another lab. So stay tuned and we're going to go over these metering devices together. The purpose of a metering device is to create a pressure drop between the liquid line and the evaporator coil, or the expansion line, the line between the metering device and the evaporator. Though it's not present on all systems. When the high pressure liquid refrigerant is fed into the metering device at the inlet, the refrigerant flows out the other side with an immediate pressure drop. That quick pressure drop results in an expansion of a portion of the liquid directly to a vapor. We call that flashing. The amount of refrigerant that flashes depends on the difference in temperature between the liquid entering the meter device and the boiling temperature of the refrigerant in the evaporator. If the difference is greater, more refrigerant will be flashed immediately. If the difference is less, then less refrigerant will be flashed. We'll start out with your piston. This is how it looks for this particular design. A piston is a simple, fixed size hole that meters refrigerant flow based on pressure. It is essentially a piece of brass with a hole in the center. The smaller the bore, the less refrigerant flows through the piston, and vice versa. The advantages of a piston is that it is simple and can still be removed. You can also change the bore size and clean it if need be. Okay, so I took it apart a little bit for you guys to see. I took the piston on out. This is the tiny hole that I was just mentioning. When you replace it, it comes with this O-ring. You have an additional O-ring on the outer side of it, right here. And this is how it looks on the inside. To get this off, of course, you can use a good old pair of these. But make sure you hold this back side so you're not turning this entire thing and you won't damage it, because it is a little hard to get off, especially when they're old like this. But that is just how you remove it. Now, when you place it back in there, you'll replace it back in there this way. What I just did with it? Oh, here it goes. You would place it back in there this way. Now, sometimes they're a pain to get out. Sometimes they're relatively easy. But you would just pop them on back in there. You will put the O-ring back in there like that. And screw that bad boy back on. Very simple compared to the TXVs, and I'll explain that in just a minute. For your piston, aka your fixed orifice, how it works is a small, non-adjustable opening lets a predetermined amount of liquid refrigerant into the evaporator coil based on the pressure difference across it. The pros to a piston is, like I just showed you, is simple, inexpensive, fewer parts, and durable and easy to install. That was a very easy, clean way to show you guys how to install it. You can do it under 5 minutes. Now the cons will be they are less efficient as it can't adapt to changing loads. It can allow liquid refrigerant to return to the compressor in low airflow, potentially causing damage to the compressor. Now, it is best for budget systems and low SEER ratings. Now, for your TXVs, your thermostatic expansion valves is an active adjustable valve that senses evaporator temperature to modulate flow, maintaining optimal superheat for higher efficiency in varying conditions. The TXV can vary the amount of refrigerant flow through the evaporator by opening and closing in response to the evaporator heat load compared to a fixed orifice, aka a piston. A TXV operates more efficiently in varying environment conditions, theoretically at least. For your TXVs, how it works is it uses a sensing bulb on the suction line to detect evaporator outlet temperature. It adjusts an internal pin to open or close the valve controlling refrigerant flow to maintain a constant superheat, vaporizing all liquid refrigerant. So inside there will be a needling pin that will internally cause it to open or close the valve, and that will control the refrigerant flow to maintain a constant superheat. The pros would be they're more efficient, at least I believe 15% better than pistons. It adapts to load changes. It prevents liquid slugging, meaning it's more protecting of the compressor. Better cooling. It simplifies charging by using the sub-cooling method. The cons would be they're more complex, they're more expensive, more components that can fail. Those bulbs, sometimes if you have to braze these in or when you're replacing them, you have to really keep them at a certain temperature or they'll damage very easily. Though often due to installation issues and debris, they do fail, but they are supposed to be more efficient and more adaptable. They are best for high efficiency systems. They're more modern for HVAC and commercial refrigeration. The key difference is control. Okay, the pistons offer a fixed flow, while your TXVs dynamically adjust refrigerant to match the cooling load, preventing liquid flow back and improving performance. Now, for your system charging methods, the primary method of charging a system changes based on the type of metering device you are dealing with. A piston system uses the superheat method of charging, and a TXV uses the subcooling method of charging. It is important to note that pistons and TXVs are not exclusive to either straight cool or heat pump systems and can be installed on both, provided the correct type of application that is being used. The key difference lies in how they accommodate the reverse flow of refrigerant when dealing with a heat pump system. So for a piston, pistons are commonly found in residential straight cooling and heat pump systems. For your straight cool systems, a single fixed orifice is installed in the indoor evaporator coil to meter the refrigerant flow during the cooling cycle. Now for your heat pump systems, in a heat pump, the refrigerant flow reverses direction when switching between heating and cooling modes. Okay, so some older or basic heat pump systems use a single specialized biflow piston that can slide back and forth in its housing, seating itself to force refrigerant through the orifice in the correct direction for each mode, while allowing free flow in the opposite direction. Now, for other heat pump systems, you may use two separate fixed orifices, one in the indoor unit for cooling mode and one in the outdoor unit for heating mode, each with a bypass check valve for the reverse flow. For your TXVs that are your more advanced metering devices, offering better efficiency than a fixed piston, especially under varying conditions like I was stating before. With straight cool systems, a standard TXV is used, which meters flow in one direction only for straight cool systems. But for your heat pump systems, TXVs for heat pumps must have an internal or external check valve to allow for the reverse flow of refrigerant during the heating cycle, bypassing the metering mechanism when flow is in the reverse direction. Without this check valve bypass, a standard AC only TXV would not work in a heat pump application. Many modern packaged heat pumps, they use, and my limited experience with that would be like a single biflow TXV to meter in both modes. Key takeaway for that would be you would choose a TXV for efficiency and performance, especially in hot climates. If you're in Houston, if you're in California, you're in Nevada, you're in Georgia, or you use it for high-end systems. While a piston offers simplicity and lower upfront costs for less demanding applications. In conclusion, though, both types of metering devices can be used, but the specific components must be designed to handle the bidirectional flow inherent in a heat pump system. You guys stick around to the end. I have your cheat sheets for you to be able to go over everything in a written form that I mentioned in this video. I hope this helps.